All right, guys, hey, let's talk about volume. Today we are focusing on volume of spheres, cylinders, and cones. So our drawing of a sphere is going to look something like this. Cylinder is kind of like a rectangular or triangular prism, but the base of that prism is a circle. So think kind of like a Coke can. And then cones look a lot like an ice cream cone. They can be upright like that, or they can be upside down like this. Okay. In 8th grade math, you're given these formulas. So let's look at formula for volume of a sphere is V equals 4 over 3 pi r cubed, because volume is three-dimensional objects. So our units are going to be cubed, 3D, third exponent. V in this is going to represent our volume. And then because we've got something that's based in circles, R is going to be our radius. Typically for pi at this level, we are using 3.14, or sometimes you are asked to use the approximation 22 over 7. And the volume problem will specify what it wants you to use. The cylinder formula is V equals pi r squared h, where pi r squared represents the area of the base, which happens to be a circle, and so area of the base times height. R in this is also radius, and then h represents height. And then for a cone, we have V equals 1/3 pi r squared h. So let's look at how we use these in examples. First example, given a sphere. And we are going to label the center of the sphere here, and that is marked as 3. So this 3, because it only goes across half of that circle, is going to represent our radius. So we can label, we know the radius is 3. And I'm going to tell you specifically that we are going to use pi equals 3.14. So let's go ahead and plug all of these values into our formula, and then I'll show you how to put it in your calculator. So V equals 4 over 3, and that's always 4 over 3. Pi, we're going to substitute to 3.14. When we substitute, we should put our values in parentheses. And then the radius is 3, and that is to the third power. In my calculator, I'm going to put this in exactly how I see it. So my fraction is 4/3, parentheses 3.14, parentheses 3, and then to enter in that exponent of 3, I'm going to press this button right here beneath pi. That's our exponent key, and then our exponent is 3. So you can see that puts it right up there. And when I press enter, I get my whole answer, and the volume of this is 113.04. And that's it. Let's look at the next one. We're going to have a cylinder here. Here is the top of our cylinder. We're going to label that with a radius of 6. Sometimes you're going to see the base. This is written in dashed lines as if you're looking through the figure. And we're going to label this guy over here as 11. So we can write out what we know on the side. We know the radius is 6 and the height is 11, and we can plug this in. But before we do, we want to use 22 over 7 for pi, so you can see what that looks like. So let's go ahead and do our substitution step. V equals, substitute 22 over 7 for pi. The radius is 6, and that is squared, and the height is 11. And again, I'm going to put this into my calculator exactly like this. So, parentheses, 22 over 7, close parentheses, times 6 squared times 11 equals, we're going to round this to the nearest hundredth, so 1,244.57. V equals 1244.57. There we go. All right, for our last example, let's do a cone. For this cone, we're going to mark this as 10 and this as 12. This 10 represents the diameter of that circle because it goes all the way across, but we don't need the diameter. According to the formula, we need the radius. So if the diameter is 10, that makes our radius 5, and our height is 12. And it's not going to specify what we want you to use. And when it does not specify, you're using the button for pi in the calculator. So when we do our substitution, we're going to put 1/3, leave pi, like so. R is 5, and that's squared, and the height is 12. In the calculator, I'm going to put 1/3 in my fraction, and then that pi button is right here. So I'm going to press that, and your calculator is going to show the pi symbol, and then we're going to keep going. 5 squared times 12, and that gives me 100 pi. But it doesn't want our answer in pi, it wants our answer as a decimal. So if we press the mode button, and we go down to classic versus math print, I can press second and mode to go back. That was 100 pi, and when I get that, we're going to round to the nearest hundredth, so that's 314.16. So again, you hit the mode button, make sure that you are in classic to get a decimal answer so that you don't end up with an answer in terms of pi. Let's look at some quick examples, some practice really quick, and then that'll be it for notes for today. So here are our practice problems. First one. All right. We can identify this shape as a cylinder. Our cylinder formula is pi r squared h. So we need to know the radius and the height. The radius is marked here. If that's hard to see, that is a 2, and the height is 7. Go ahead and write out the volume formula equals pi r squared h. And let's try this one, leaving our answers in terms of pi. Let's see what that looks like. So if I want my answer in terms of pi, I'm going to leave pi in my formula. I'm going to plug in 2 for r and 7 for h. But really, if I want pi to be in my final answer, that means in my calculator, all I need to evaluate is 2 squared times 7. 2 squared is 2 times 2, which is 4, and 4 times 7 is 28. So if I want this answer in terms of pi, it's just 28 pi. Now, if I wanted my answer in terms of, if I want to use 3.14 as pi, then all I would have to do is take 28 and multiply it by 3.14 to get an answer, which should give us 87.92. So for these next two examples, we're going to do one of each of the other ones. I want you to give your answers in terms of pi and then substitute 3.14 in to get a final answer. So we're going to do 2 answers per question. Okay. Let's do our next one. All right, we can see this is a sphere. The formula for a sphere is 4/3 pi r cubed. This time we do have units of feet in here, and we know that our radius is 5. I will need to include my unit in my final answer. So let's go ahead first and do our substitution step and then our answer in terms of pi. So V equals 4/3 pi, substitute 5 in for r, that's cubed. Just like on the last one, if I am trying to leave my answer in terms of pi, I'm ignoring the pi. So in my calculator, I would take the 4/3 and multiply that by 5 cubed. So this should give me, in terms of pi, 166.67 pi. And then if I just multiply 166.67 times 3.14, that gives me a final volume of 523.34 feet cubed, because this is a 3-dimensional. I am cubing my radius, so it has to be to the 3rd power. Cubic feet is the other way that you might hear this. All right, last one is a cone. So for our cone, we're going to label this 8, and then here is going to be 10. The formula for volume of a cone is V equals 1/3 pi r squared h, where we need to know the radius and the height. My radius is marked as 8, my height is marked as 10. So let's do this in terms of pi. V equals 1/3 pi 8 squared times 10. In the calculator, in terms of pi, we would take 1/3 times 8 squared times 10. Now, if you have this in math print, it may give you an answer of 640/3 pi, or it may give you 213.33 pi. It really depends on the mode that you're in. Both of these would be equivalent. And like if you saw 640/3 on your test, but this is what came out of your calculator, you know you can just do 640 divided by 3 to make sure that they're equivalent. And then last part is going to be if we want to substitute 3.14 for pi, we would take 213.33 and multiply it by 3.14, which would give us a total volume of 669.86. And that's it. That's volume.